Hey, pool chasers. Have you ever walked up to a new account, took a stroll into the backyard, started your assessment of the pool, and then got to the pool equipment and felt completely overwhelmed? I know we definitely have. It's even worse if the plumbing is not labeled, right? I mean, how do you know what valves do what? Well, one of our favorite parts of this episode is when our guest today explains what steps he takes to determine the function of each plumbing line using a strategic method that you can try yourself. Once we learned the terminology and how things were designed, it got a lot easier to understand. That's why this episode is such a good one for those beginners out there and a fresh reminder for those that may be more advanced. In this episode, we also go over how a plumbing system works, how a skimmer and weir door work, plumbing leaks, what PVC glue to use, what tools and parts you need on your truck, and best practices when it comes to plumbing in a new pool, replacing existing equipment, plumbing above and below grade, and more. I know that sounds like a lot, and it definitely is, but all of it is relevant though when it comes to the world of plumbing. We all know that knowledge is power. So take some notes on this one and enjoy episode 109 with Justin Bowie of JMax Plumbing. Welcome to your go-to podcast for the pool and spa industry. My name is Tyler Rasmussen.
And my name is Greg Villafania. And this is the Pool Chasers Podcast.
All right, well, thank you for joining us today, Justin. We appreciate you coming back here in the studio with us.
Thanks for having me, guys. It's an honor to be here.
Absolutely, man. So we heard a little bit of your story on episode 12 with Jeremy, but can you tell us again how you got into plumbing and a little bit more about your company, JMax Plumbing?
Absolutely. So I had recently moved to Arizona from Maryland. I was in community college, just kind of getting some credits down to hopefully transfer to ASU. And I met a guy there who was a pool cleaner. So started out pool cleaning with him, just kind of on the side, doing half school thing, half work. And was young, ambitious, knew I wanted to have my own company one day. Wasn't necessarily looking at pools at all, but we were cleaning pools. I liked it. We went by a job site that was being plumbed in the Greyhawk Community Center. Saw these guys plumbing it. I was intrigued. I was like, that looks like I could do that. That looks easy. It's construction. It was the first time I'd really seen a pool under construction. Where I'm from, there's not a ton of pools. Arizona, they were everywhere, and I was seeing them every day because I was cleaning pools. So my father was a home builder. He had some relationships with Shasta and some other big pool companies, and I asked him if he could connect me with one of those companies to see if I could become a pool plumber. And he did. He connected me with Shasta. Jeff asked, and I went and talked to him. He ended up connecting me with their subcontractor pool plumber, kind of talked to him, started out at the very bottom, was just a ditch digger, learned the trade from the bottom. I worked for a crew there for a couple of years, a little shy of a couple of years before I was able to get my own truck, which was a really fast turnaround to go from the bottom to having your own truck. I think at that time I was one of the fastest to make that transition. Working there for a while, took what I could from learning from those guys, worked myself up the ranks, eventually ran his company for him. Basically, he hired me on as like his general manager. Did that for 5 or 6 years, and then the recession started to hit. Kind of looked at other options. I knew I wanted to start my company. I'd kind of maxed out on growth there with things, scaling back because of the recession. It just seemed like the right time to go out on my own and kind of make my own name. So I did that right in the mix of the recession, went out on my own.
What was your understanding of plumbing prior? Did you want to go to ASU because they had one of the best water engineering programs in the country, or is that U of A?
I'm not sure. At that time, my only focus was construction management. I wanted to get into the Dell Webb School of Construction. So I think originally it was more likely I was going to become a home builder or in the trades, maybe a framer. That's what I grew up doing from the time I was very young. My father was a lifetime home builder. My best friend, his father, was a home builder, custom home builder, and I worked for him all through high school. So I think it was very coincidental that I ended up seeing that crew plumbing that pool. I was cleaning pools. I was interested. It was very much kismet, or whatever you call it, when all the stars aligned. And then, obviously having the ability to work my way through a company and having the opportunities I had there. At the time I took that position, there was no general manager there. So it was a lot of star alignment, I'd say, that ended me up there. But never had any interest in water or anything like that until I got into that business.
Right. And talking about history a little bit, one of my favorite pictures is you, young Justin Bowie. How old were you in that? There's a picture in your office.
Yeah.
It's a little reminder of being in the trenches, I'm sure.
Yeah. So that picture, I was 19 years old. That was 1999. And that was when I was still a helper, but I was transitioning from a helper into being a crew lead. So yeah, I was doing a repair, had my shirt off. It was 145 pounds, buddy. Lean,
Wet.
mean, yeah, wet, dude. It was bad.
I know you had them interstate shorts on, no?
Yeah.
Ooh.
Yeah, I had some
Jean short.
had some cap toes or whatever they're called. You know what's funny about that is in Maryland, everybody works with their shirt off. Everybody out here, like I must have looked like an idiot because I didn't come from here and like you don't know what the sun does to you. But I never worked with a shirt. It's retrospectively that's pretty unprofessional, but
Yeah, you don't see it very often. I
No.
even see people running around here with no shirt, and I'm like, whoa,
yeah,
whoa,
Yeah.
you're gonna get yourself in trouble.
yeah.
It's always a dude with the big gut that's running around now. Like, who told you could run with your shirt off?
Yeah.
Like,
There's a dude, he has not lost a pound that rides his bike by my house every single day. I'm like, dude, I'm glad you ride that bike because I don't know what
plateaued.
would happen if you didn't.
I mean, I'm a big boy, man. You learn that stuff. You swim with the shirt on. You don't run without a shirt, man. You should know, like, once you get that gut,
Yeah.
it doesn't hang out well.
Some people let it all out, man.
I guess.
So when you were cleaning pools, were you doing anything plumbing related, or were you just cleaning pools?
No, absolutely. The guy that I was cleaning pools with, it was his company. He was a single pole guy, and he would do all his own repairs. So we would do cleanings throughout the week. I forget the days. It was maybe 2 or 3 days, and then there would be one day dedicated to repairs. Whatever we came across in the route that wasn't an emergency, we piled into one day and we did those repairs. So I did learn from him. Although I look back now and I was taught horribly from him because the way he did things was nuts. But yeah, that was the first time I ever touched plumbing or anything like that. So
That's an interesting point you bring up because, like, we always talk about that's how people learn in this industry is like whoever teaches them.
Yeah.
That's just what they run with. Like, they think they know exactly how to do it, and they get taught in a weird way.
Yeah, 100%. It's very unstructured, I'd say.
And do you remember where that turning point was where you wanted to further your education in terms of plumbing and hydraulics?
Yeah. So when I came up in the trenches at that prior company, it was just like you said, you just learn from whoever you're with. And I started to become interested in hydraulics when I met guys like Dustin Petros, John Mortensen, other big names in the industry that were doing, large scale jobs, say. And when you're doing residential in general, you're given a plan by a builder that you don't necessarily need to do any of your own support hydraulics. And I'll explain the difference between hydraulics and plumbing so you understand. You can be a plumber and you can do plumbing. And what that means is you're installing the pipes, you're running the lines. Hydraulics is actually the science of it. It's the properties of the water and how they are in the system. So a lot of guys are plumbers and maybe they know plumbing, they can follow a plan set, but they're not masters of hydraulics. They don't understand the implications of what they do necessarily. They may have some basic understanding of it, but that's the difference. If you understand hydraulics, that means you know not just what to install, but how and why you're installing what you're doing. That's the difference.
I wish they would have, people with like hydraulic cars would have came out with a different word, because when you Google that, you got to be real specific because you're just going to see lowriders, and I love a good lowrider. So,
Yeah.
you end up going down that rabbit hole.
Yeah, you're right.
But thank you for explaining that, because I think that word was something that we thought didn't apply to us when we were in pool service. But, after talking with you, we understand that hydraulics is really just that science, and it is applied pretty much everywhere that water is needed, because, you're talking about even dams being built, and they're putting like different water in different places, that the science of hydraulics is being applied everywhere. But plumbing is the work that needs to be done in order to do that.
Yep.
Because I'm sure there's a ton of, you're doing schematics and data. Can you explain that real quick? I know you do that a lot, but can you explain what, schematics are for plumbing?
Sure. So schematics are basically the the one line drawing of all of the plumbing in the pool. So a schematic would have your pumps and filters, and you would have all of their suction lines and return lines, where they go in the pool, what size they are, and how they connect at the equipment set. So that's a schematic. It basically tells a plumber, okay, these are these lines, what size I'm running, where I'm running them to, and how it should be valved. Basically, that's what a schematic is.
For sure.
Yeah.
And when you're looking at a job, just real quick, I know we're going to get into the basics of all of this, but for one job, is that usually across the board where it's the builder, whoever's doing like the interior finish, digging, all that? Is that person looking at the same schematics you are, or are they all different?
So the schematics are specific to the plumbers and maybe the electrician. The electrician might have to take a look at it so he knows where to put automated valves, or he may need to know how many pumps, what size pumps. But in general, nobody else sees it, I would say. It's really just us. Some companies like Premier Paradise, Jeremy, guys like that, they print them out on their plan sets. Us, for most of our builders, we're generating the schematics from scratch. They don't do anything, and we just hold on to them internally. Sometimes we'll give them to them for their startup guys, so their startup guys know what they're doing. In general, I'd say the plumbers see it, and maybe some electricians.
Right.
Nobody else really needs to.
Sure. In laying like the conduit for electrical and things like that, is that considered plumbing? I mean, just that piece of it?
I don't think it crosses into the plumbing realm. Plumbers do some low voltage conduit. So, I mean, I guess you could call that part of the plumbing scope, but it's certainly
because it's the hole's already there and you might just be laying it out.
And it's plastic, but it's a totally different set of codes that it adhere to it and everything. Okay. It's completely different.
So on the job site, the electricians come out and do their own piping to run that?
Yep. They come in and they use some of the same techniques as us, like heat bending and stuff. But yeah, totally different.
Cool. So let's jump into kind of some basic overview. Can you explain how a pool system is designed to work exactly?
Yeah. So you could break it into a couple things, and it might be easier if we start with let's start with how pools evolved. So the basic breakdown of it, you have bottom cleaning, top cleaning, you have filtration and the turnover of the water volume, and then you have like your skimmer, for example, which we'll get into right now. So if you start with the very first pool that probably was ever built, it was probably a hole in the ground, right? And they decided, okay, we got this hole in the ground, but the water gets dirty, cloudy, turbidity's high, right? So they said, let's add a filter. So they piped in a pump and a filter. It probably drew suction from the bottom, and it returned water to one location in the sidewall. The next step was they probably went, there's debris always floating on the surface. What do we do now? Well, let's add a skimmer so that we can clean the top. So now the plumbing system has evolved from just taking water from the pool and returning it back filtered. Now it's actually cleaning the top as well. So then the next thing they said is, well, if we took that water that was coming back and we placed it in particular locations, it might force debris closer to the skimmer. So now you've taken that one return, which was just delivering water back that was filtered, and it's gone around the edges of the pool and it's directing the surface debris to the skimmer. From there, the next evolution was probably, well, what could we do better? Let's look at something to clean the floor, because the floor doesn't stay particularly clean now that the surface is clean. So they started with whip systems, which I'm sure we've all seen in this. If you're in this industry, there are those holes in the side of the pool that like have tails that stir everything up. Came out with pressure cleaners and vacuum cleaners, which run around and clean the pool. And then ultimately the in-floor system, which I think is the best iteration of floor cleaning. And that's, for those of you guys that aren't familiar with that, what that is it's basically similar to a sprinkler system in that you have zones of in-floor cleaning heads that pop up from the floor. They fire 3 to 5 at a time generally. They stir everything up. They force it to the drain and it gets cleaned out. So kind of the evolution of the pool, that's how the plumbing system worked. It was always just to take water from the pool and return it back filtered, and to turn over that entire volume of water. And then along the way, we added things like in-floor and skimmers and placement of returns to make the system more effective. But at the heart of it, what that plumbing system is doing is turning that volume of water over and cleaning top and bottom.
Very good. And that is pretty much hydraulics, right?
Sure.
Like that is kind of the process of how water moves from one area to another is kind of the science of hydraulics, right?
Yes, I would imagine when pools were first built, there was very little taken into consideration in terms of hydraulics. As things got more advanced, that's probably when they started looking at, why are we having cavitation in this pump? What is the correct size plumbing? What are the velocities that we should be building these pools so that pumps are ending up in their efficiency curve? And I think it just, as things got more complex, hydraulics came into play. I don't know because I wasn't there, but I imagine those first iterations of the pool being built were not very hydraulically sound, I'd guess.
Right. And what does the process look like from when you turn a swimming pool on? Because I'm not going to fully explain it, right? But the pump is sucking the water from the pool, and that is coming from the skimmer and the main drain.
Right.
You want to talk about a little bit about just that, the process the water's going through?
Sure. When you first fire up the pump, the main drain in a very basic pool will be slave to the skimmer, which means that the main drain in the bottom ties into a port on the skimmer. You have a satellite valve in there, which will allow you to complete the circuit between the suction from the pump and the drain, and also leave a little bit of suction there for the skimmer. So that's a slave drain to a skimmer. So you got water coming through the drain, being forced there by the satellite valve. You have water being drawn in over the weir door of the skimmer, and then it returns back to the pump. The pump picks it up, passes it through a filter, comes out of the filter, and goes back to a set of surface returns. This is a very basic setup, but that's exactly how it works.
Right.
So
I'm just going to pick your brain on a few of these different things. Can you explain what exactly a weir door is doing?
Sure.
Because I went down this rabbit hole of what a weir is, and just in all uses of the world, it's pretty crazy that it's taking water that is moving uncontrollably and it's pretty much smoothing it out so that its flow can be controlled. Can you just talk about, a weir for a pool and how important it really is? Because I know when I was taking care of pools, I actually didn't really quite know what it was for, just that it needed to be replaced when it was broken.
Right. What a skimmer weir does is it does a couple things. One is it floats up and it only allows the top surface of the water to come into the skimmer. So it has a buoyancy in it, like a piece of styrofoam or whatever, so that when the skimmer is drawing water in, it's resisting through buoyancy some of that, and it's only trimming the top quarter inch. And the reason you want that, two reasons. One is because all of the debris that you are focusing on is in that top quarter inch, eighth inch, whatever it is. So any water, if that door was all the way down, 80% of that water height would be wasted. You would just be drawing water in, and what you really want is to only get that quarter inch. And by reducing it up, you're increasing the velocity that water's coming in. So if you had to take all the water in the top 8 inches of the pool and pull it into the skimmer just to get that top quarter inch, it would take a lot longer than if the weir door was up. You're only letting it in a quarter inch of depth over the whole surface area. So that's the first thing it does, is it increases the velocity, pulls only what you want, which is the top quarter inch or so of the water. The other thing it does is when the skimmer stops, when it goes static, the water and debris that are in the skimmer that want to come back out, that door acts like a check valve. It closes all the way up to trap the debris in there until the system's back on or until you clean out the basket. So that's really what you're doing. You're focusing on that top layer so you can get the most debris in, and then you're also trapping everything in the skimmer.
Right. And can you explain what velocity is exactly?
Sure. Velocity is how fast the water is moving. So in hydraulics, there's a lot of times we look at velocity. In the case of a weir on a skimmer, that's definitely something that you want. The more velocity you have at the top, it has to do with how narrow that nape is which nape is the height of the crest of water that's coming over the weir edge.
And are you figuring out the velocity by like gallons per minute? Is that how you're pretty much figuring that out?
Absolutely, yeah. There is a calculation for, especially in overflow pools, for how much weir nape you give, and it's a calculation based on per linear foot. So this is getting away from the skimmer, but if you had a knife edge pool and you wanted to generate an eighth inch of nape, which is, you basically, as the water ran to that weir edge, it would crest an eighth of an inch. You would feed it 1.6 gallons per minute per linear foot. So that's hydraulics right there. That's, if you have 20 feet and you feed that edge 1.6 gallons per minute times that 20 feet, as the water crests, it's going to be a consistent 1/8 inch of height across the top of that edge. So that's a little bit different than a skimmer, but that's a good example of.
That's very cool, because just hearing that, you should understand how important it is that it's built correctly.
Right.
We're talking about the plumbing, but we've seen pools with a knife edge that is not balanced.
Level.
It's not level, and you've got water coming off one end and not off another end. So there's definitely some issues right there. I want to circle back real quick to the skimmer, just because I think that is a big piece. I have a lot of questions on that. What are some of the components, within the skimmer? Because a lot of times we'll see like different ports down there. You'll see different things in there. We just talked about the weir, but maybe you could just explain some of the different components of a skimmer.
Sure. So in a standard skimmer, you have the weir and you have the basket. That's pretty much all you get. You'll have a satellite valve too, So you have the weir door.
And what does that do exactly?
The satellite valve. So if you look in the bottom of a skimmer, you'll have 2 ports on a standard skimmer. The suction port is the back port, and that's the one that goes to your pump. When you turn on your pump, the back port is going to draw water in. The front port goes to your main drain, or in some cases an equalizer, which is just where it stubs out the front. And what goes on top of those 2 holes is a satellite valve. And that satellite valve is there to basically complete the circuit between the back suction port and the front when you want it. You can adjust to some degree how much suction crosses those 2 ports and how much is left to be drawn straight down through the skimmer. But you could basically think of that satellite valve kind of like a 3-way valve, where you can force it to draw from the front, which is just going to your drain, or you can allow it to go to the skimmer.
I've actually never adjusted one of those. Where do you adjust that on the satellite?
If you flip it over, it's got a teardrop flap
Okay.
and a hole. And the less you cover the hole, the more it draws down the float, and the more suction you will have to the front port. So the more you close it, the less suction that you're going to have at your skimmer. Unless I got that backwards. But anyway, that is where you adjust it. It's the little teardrop on the bottom of it.
Yeah, so I could see that probably being more important when there was a lot more single speed pumps out there.
Sure.
Where you could actually probably dial back the suction a little bit.
Yeah, it works a lot on like pools that don't have suction valves in front of the pump.
Yeah.
You'll see that on a lot of the old pools. That's how you would control the suction between your skimmer and your main drain, by changing that valve
Exactly.
underneath. And now we have, a lot of our plumbed in with Jandy valves in front of the pump, so you can control it a little bit differently. But before that, that's what those were super important for, was to alternate between the 2.
The other thing they do is if you run dry on your skimmer, there's a float in them that drops. And then it just completes the circuit straight to the drain, so you're not sucking in all the air from a dry skimmer.
Yeah, so stop pulling them out, all you pool technicians, because they actually are important and do something.
Yeah.
And if the flap is broken underneath, it should be replaced.
Absolutely.
I can't tell you how many of those I see, like, just sitting by the pumps. Kyle and I saw one on Saturday when we were working out there. Like, they're just out there sitting. People don't know what they do. They just pull them out.
Yep.
And that's why we want to talk about all these things on the podcast, because we think it's good refresher material, but it's also good for anybody that has no idea. So we're really going to just kind of talk through a lot of this stuff. And I know it's probably been many, many years since you've talked about it, Justin.
Sure.
But we're just going to kind of talk through it, because I'm just now thinking of tons of questions after thinking about when we used to take care of pools, whether you didn't know if something was a good idea or not. So this leads me to my next question. What are your thoughts on vacuuming a pool through the skimmer? Because there's a lot of different ways that you can do it, but do you recommend, making sure that you're sinking a hose and it's full of water? And, how would you recommend, removing the hose? I don't know if it's when the last time you've done that, but a lot of people do it different ways.
Yeah.
Where they want it to suck air to get all that water out of the hose lines.
Right.
But what are your thoughts?
I learned flooding the hose for sure. I always threw the hose out on, and you toss the vacuum head in first, and then you dunk the whole hose before you stick it in. That's how I always learned. I have seen guys hook them straight up though, and then the pump struggles for prime for a second until it picks back up. But it seems reckless to me. But
yeah. And do you usually leave the equipment on when that's happening and just kind of hook it as soon as you get the hose
That's how I do it. One thing that's changing now, and this goes back to your question about what are in skimmers, is now with Venturi skimmers, it's a lot harder to use a vacuum in a Venturi skimmer because you got to pull out the apparatus that's inside of it. If it's an A&A skimmer, you'll have a balance pipe blocking the port. You got to take all that out, and then when you're done, you got to put it all back together. And then if you're using a Paramount, they actually have a new nozzle that's kind of out of the way, which is nice. You just have to remove the basket. But yeah, we try and plumb a dedicated vacuum as much as we can to give service guys some control and some maybe make their job a little easier. But anyway, yeah, I always, when I do it out of the skimmer, I leave that thing running, dunk the hose, and plug right in.
Right. And when you have a dedicated suction line in a pool for mostly if it's if you have a pool that has an in-floor system and there's a dedicated suction, it's usually just for vacuuming purposes, correct?
Right.
Yeah. And most of the time when you set something like that up, is that valve usually closed and you would have to open it up? Like, what does that look like for, say, one of your pools if you needed a vacuum?
Exactly right. So it's always closed unless you're using it. And it's when we plumb them, it's always the first suction on the pool side, because your next valve is typically your skimmer and main drain, which you're going to set that valve one time to draw 75-25, and the vacuum just becomes an on-off. So it's really important when you're plumbing, if you're plumbing a new pool, if you have a spa, it's always by itself and the first valve on the suction side. Otherwise, if your first valve was your skimmer, and let's say, and your second valve was your vacuum and your main drain, now to use that vacuum, you got to close your skimmer, you got to close your main drain, and that opens the vac. And then when you're done, you got to put it back and you got to rebalance your skimmer and main drain. You want, on a standard pool with no infloor, you want 75% of the suction at the surface, 25% at the floor. It's the opposite for an infloor. So that's a good rule of thumb. Vacuum first on its own three-way.
Very good. Back to the basics of plumbing. If you're looking at an equipment set, for the most part, what are we looking at exactly? For somebody that has never looked at a whole entire set and they're looking at one of your equipment sets and pad, what are they looking at exactly?
So we break it into, when we refer to an equipment set, we break it into a couple sections: the suction side, the pool equipment, and the return side. So everything connected on the front side of a pump is suction side. That's your suction lines, skimmers, main drains, spa suctions, booster suctions, whatever. That's all connected to the front of your pump or pumps. Everything on the return side of the filter that comes out, that's all return stuff. That's your returns, aerators, any features you have in the pool, and in-floor. So when you look at an equipment set, you're looking at the stuff generally low to the ground being suctions, your equipment, and then all of your return manifold.
Okay. And I've seen that in some of your pictures, there's a mix of different valves, whether it be ball valves. Mm-hmm. I've seen gate valves, mm-hmm. Three-way valves, actuators, different things like that. When do you know which type of valve to use?
Yeah. Some of that comes from the builder specifying what they want. And some builders use a valve that's not right for its intended purpose. For example, a gate valve is not supposed to be a throttling valve, but we use them all the time on deck closers. It's generally a low flow line, so it seems to work out. But there's a rule.
Is that what a gate valve is meant for?
A gate valve is meant for an on-off operation only. You're not supposed to use a gate valve to adjust flow. It's more of like a switch. And the reason why is because the gate is susceptible to wiggling from the flow. It can become loose. To combat that, we use a Schedule 80 gate valve, which has a really tight fitting gate. They're great. They're way more expensive. They're serviceable. The head comes off. The brass ones we've had a lot of problems with those. The gates corrode. They fall off. The stem gets trapped. It's a nightmare. But to answer your question, so builders will specify, sometimes they will say, I want gate valves on all my deck closers. I want ball valves, or I want two-ways. We have our own set of rules that we use. You always use a three-way anywhere that you're trying to divide suction, or in a situation where you need to close something to open something. We use two ways when we can on areas that you want to be able to service the valve. They even have ball valves that are serviceable. They're just way more expensive for like a residential pool. You don't get into those too much. So we have a set of rules, builders have a set of rules, and I would say everybody has, from their experience, developed those rules. What works best for them. We certainly think we know what works best, but we will definitely follow their rules if we have to.
Right. And what exactly is like a manifold, when it comes to plumbing? Because I've heard people, if you've got 4 ball valves and they're all, kind of the same height. And
Right.
I've heard that terminology, manifold. Can you explain what that is exactly?
Yeah, so a manifold is, just think of it like a splitter. So you have water that feeds the manifold, and then everything leaving the manifold is an option, say. So the manifold is a collection of valves that distribute water from the pump. You can have a suction manifold, return manifold. That term just means collection of plumbing lines coming into one with valves, I would say, is the most simple way to describe that.
Yeah, and I've seen you talk about it like on your Instagram and stuff like that.
Yeah.
Like looped manifolds and
Right.
things like that.
Yeah.
For like the shears and different things like that. And I think that's pretty cool. That's really, like you said, kind of the definition of hydraulics right there, where you're taking this water and it's kind of distributing it. The same. Is a loop manifold, obviously that's going to be something different, right?
Yeah, loop manifold, that's advanced for sure. There is some things.
Oh, I went way off. Okay.
Well, no, I just mean loop manifold. The difference between a loop manifold and a valved manifold is a valved manifold, you feed it pressure and flow, and then the ball valves control the water exiting it. And you can independently set all those. So if you had 12 features on a valved manifold, they could all be 12 different things, or you could balance them if there were some inconsistencies, like if one was higher than the other at the pool. That's when you use a valve. Use a loop when there are 3 identical features at identical elevations, and you don't necessarily need. But the problem you run into with a loop is it's very hard, and it's a lot of plumbing to make a loop a true even flow loop. You have to feed the loop at multiple places. You got to make sure that there's enough pressure retention in the loop that it can feed everything the pressure it needs. That's advanced for sure.
Right. And for what instance would you use the first, what was the first manifold? Valve manifold. What would you use that for exactly?
If you had a booster pump that was producing 240 gallons a minute and you had 5 or 6 features that were 30 to 40 gallons a minute, all different demands, or let's say they were all the same demand, but they were at different elevations at the pool. And what that means is, maybe one is a deck jet, it's at 0 deck height, and the next one's a shear, which is plus 2 feet. So you need a way to control flow to those. They have different demands, or they're at different heights. The higher something is, the more resistance there is in the line, so it needs a little bit more pressure to overcome that head. So that's where you valve it. You got separate things, separate demands. You need to even them out. You use valves. The only time you use loop is when they're exactly the same feature, exactly the same elevation, and exactly the same desired look from that feature.
Right. And for the most part, I just wanted to bring up the loop manifold just so people don't get it mixed up with valve manifold. Yeah, because the loop manifold, it looks like from photos that it's usually by the feature.
Correct.
So if it's like a shear, it's going to be kind of right behind that feature.
That's true too. Yes. The valved manifolds, you can put the valves wherever within reason. And then the loop exists by the feature. So totally different there.
Right. Very good.
You talked about Venturi skimmer earlier. Can you just explain? I know that's getting more popular.
Yeah.
How that works. Sometimes you'll see it plumbed in like a quick skim, they call it.
Right.
Right. But people see the quick skim line. I always see those shut off because people don't know what they do.
Yeah. Yeah. So a quick skim. So basically, a normal skimmer works in the range of 27 to 54 gallons a minute. That's the target for a skimmer to get it to operate properly. So what's cool about a Venturi skimmer is you can feed it 6 to 10 gallons a minute on the return side. So it's not suction water. It's actually water coming back from the return from after the filter. It feeds it through a nozzle, which accelerates that stream. Water, when it's accelerated, or water in general that's moving, has friction. So it pulls other water with it out of the skimmer, which creates Venturi. That is Venturi. And then it draws water over the weir. So a Venturi skimmer acts just like a suction skimmer, except it's using 6 to 10 gallons a minute of return water instead of 27 to 54 of suction water. Why that's advantageous is because if you have an infloor, you want as much suction at the drain, which is where you're removing the heavy debris from the infloor. So if, like, let's say you had an infloor pool and you had 2 skimmers or even 1 skimmer and a drain, well, chances are you're not going to have enough suction at that drain to effectively remove debris, or at least not as good as it could if it had a Venturi skimmer, because you free up all that suction. If you had a pump making 97 gallons a minute, and you can remove 27 gallons a minute of that production by using a Venturi, now you got 97 you can dedicate to the drain instead of 70, and all you're giving up on the return side is 6 to 10. It's a no-brainer. So it's and you can also look at it like energy savings, like, the cost of production of 27 to 54 gallons a minute out of a pump versus an extra 6 to 10, you're using less energy. So
yeah, the technology is pretty awesome.
It's great.
People don't really understand it, and you'll see them shut off all the time.
Yeah.
And part of that is because it's hard to vacuum. I think the technicians, just shut it off and pull the thing out because it's always in the way.
I feel like they turn them off because they're always like, oh, it's robbing flow from the infloor.
Yeah, maybe.
Like, I need this infloor to work better. Let me kill this extra 6 to 10 or whatever.
Yeah, but it's good, like you said, especially in infloor. It would be nice though, like I think you guys do it a lot, is plumbing in a actual vac port, separate, which a lot of people don't, which is, that's why it's frustrating. But
I can't imagine.
I always got to stick up for the pool guys, because it's difficult going into a new backyard. Like, you take care of one pool that had this plumber, this builder, this manufacturer equipment, all these different things, and then you go to the next pool that is completely different, and it just goes on and on and on and on, where there's like no standards, like at all, where it's just the next pool could be somebody that the homeowner, watched a YouTube video on how to build a pool under $3,000, and you really have, idea what's going on.
Right.
So I think, sometimes, lose sight of that. It could be really difficult.
Yeah, that's why it's so important to learn the terminology and learn, what things look like. And then, because like if you see the word quick skim on an equipment set, if you don't know what it means, then you're not going to know how to use it. But if you kind of understand that, then you can maybe adjust some stuff on certain pools, and you making yourself better and learning those things helps when you walk into a backyard and you start to see those things. Oh, I heard that term before. Or you can go back to the podcast and listen right now here.
Yeah.
Like, oh yeah, I heard that one time.
Well, anybody listening to this and you work for somebody, you become a huge asset to the company when you take the time. You might not be getting paid for it, but you're taking the time to see something new. Maybe take a photo of it, do your own research, call the manufacturer, anything like that. And you understand how that works to its fullest potential and degree. And you just became a huge asset to that company, or for any other company for that matter. Knowledge is power. Firmly believe that. There was a handful of people that came through that really knew their stuff, and they were always the most valuable because of their knowledge base.
Yeah.
You'll start to impress owners when you start talking different terminologies like that. And if your current owner doesn't appreciate it, somebody will definitely appreciate it and pay you more for it.
Agreed.
Don't get too cocky.
Relax, guy. You're not worth 40 an hour, okay? I'll tell you that right
now. Awesome.
Our passion to seek pool industry knowledge and being able to share that knowledge with you is the reason we started Pool Chasers. Turns out Pentair has several ways for you to gain knowledge as well. Take, for example, the Pentair Master Service Program. This is a program designed to recognize dealers, service technicians, and other pool professionals for completing desired training modules. It gives you the tools you can use to troubleshoot Pentair installations in the field and become a master of Pentair product knowledge. Be rewarded for educational activities designed to enhance your Pentair knowledge as you move through the certification levels. With 3 levels to work through, becoming a certified Pentair professional has never been easier. It's training that rewards you and your business. But the real value comes from building your confidence in the field to ensure the customer loyalty you need to keep your business growing. We encourage you to check this out. So to become a certified Pentair professional today, visit pentairpartners.com or click the link in the write-up below.
Well, can you explain to us some best practices when plumbing in a brand new pool?
Yeah, so A couple things to take into consideration when you're plumbing a brand new pool. I'd say the first is the routing, how you're going to lay out your plumbing. You want to avoid as many hard turns as you can. Obviously, efficiency is important. The less hard turns you make, the less resistance there is in the plumbing system. So that would be one major thing, is plan out your routing. Figure out where you can run pipes using the least amount of fittings as possible, most direct path. Check the sizing from the builder that they gave you. Try and verify it. You don't have to be a hydraulics expert to just know what the capacity is of each line. It's easy, that information is readily available online. Or you can even email me and I'll give it to you. And you could just look and say, they're asking for 8 therapies. 8 therapies are 20 gallons a minute. It's 160. I need a 3-inch line for that, And so just verify that all the line sizes you're being asked to install are the correct size. Because it doesn't matter how many, if you use no fittings, it doesn't matter if that line is undersized, you're just not going to get it done. Or that pump's going to be cavitating or whatever could, depending on what the line is, it could be discharge cavitation or anything. So use the right glues. That's another thing that I see a lot of plumbers don't understand, that there's different glues for different applications. There's a lot of products in the pool business, some skimmers, some water levelers, deck chlorinators that are ABS. They're molded out of ABS, which is a harder plastic, and there's a specific glue that you use to transition from a PVC pipe to an ABS product. Really important that you know your glues. There's also different colors of glues, and I think if you are an experienced plumber, you start using those differently. I know myself personally, I would use purple primer and gray glue. There's no difference between a gray glue and a clear glue unless they're a different type of glue. The difference is visibility. That's the reason primer is purple. It's so an inspector can see it, and so you know where you've applied it. You can get that same primer in clear. You have to be a little bit more confident and know that you did it, but where I would use clear primer and clear body, clear glue is on the equipment set. If you ever went on a job that I plumbed right after it was plumbed, maybe before it was painted, it would look super crisp and clear. You wouldn't have purple primer everywhere. You wouldn't have gray glue on the pump lid. If something did land on a slab, you could wipe it off and it wouldn't be a big deal. There's also different glues for pipe sizes. Most guys I see using medium body 744 for 6 to 10 inch pipe. That's a huge no-no. You got to use industrial grade 711 or whatever your manufacturer recommends for that size. CPVC, if you're doing any commercial work and you're plumbing in CPVC on like a heater system, for example, CPVC is a really strong material that's resistant to heat expansion, and there's a special glue for that. It's bright yellow, so you know you're getting the right stuff. So best practice would definitely be knowing the right glue to use for the right type of material you're working with. And then I'd say the other thing is, and I'm guilty of this too, when a new product comes out, it's incumbent upon you to understand that equipment. You need to read the manual. You need to understand what you're doing and like what it can or it can't work with. So if a new product comes out, an ozonator, for example, or UV, you need to understand how it works, how to install it. Don't just go install it. If a customer draws it on a plan and you just go do it, I think that you just can't do that. There's just too many things being installed out there that guys don't know what they're doing. They're just connecting it and walking away from it, which I think is crazy. And we see that all the time.
Yeah, I saw a photo where I'd never seen anything like it. You had like 3 ozones or something like
BioShields.
Yeah, BioShields.
Yeah.
I thought that was crazy. I'd never seen anything like that before.
Yeah, that was for Rick Chafee. We actually got called out on that post too because the inlets were horizontal. And I'd like to, whoever that was that posted that, it is still running to this day and it's not trapping air. They tell you in the manual to plumb it with the inlet outlet up so it vents itself.
And they were vertical. They were.
Yeah, these, we had them horizontal, but the inlets were also horizontal. So, technically that UV body could trap air, but they don't. So it's fine. But yeah, you got to know what you're doing for sure. Understand the product.
So what kind of issues come up in plumbing, and what indicates that it's a plumbing issue and not something else?
Yeah. So I think if I can answer that in 2 parts, one new construction and then one once it has water. So some of the issues that come up in new construction, we'll just start with that one because it's pretty straightforward. Right now, there's huge equipment sets. There's huge amounts of plumbing going into these pools that are becoming more and more elaborate every day. And I think the challenge for us is becoming, and the issue that we see the most is fitting it all into the yard. They generally want to see the equipment out of view. So we have these huge elaborate equipment sets with these big chemical management systems, big pools with big demands, a lot of plumbing. I'm not sure that builders necessarily understand going into it when they design it, how much plumbing it takes for these pools to work. And then it's not just getting it in the yard, it's getting it from the pool equipment set to the pool. They'll have a ramada, sunken bar, fire pits, footers, all this stuff. So we get stuck in this position where we got 40 pipes or 20 pipes even trying to make it to the pool. So we have nowhere to run them. We got to stack them. It makes our job very difficult. You got to get very creative, and you got to try and do it at the same time without sacrificing some of those things that we talked about earlier being best practices, right? So I think that's a challenge we see in new construction. Once the pool has water, some of the challenges we see in how we know that it's plumbing are probably the top ones that we see are leak investigation. We get calls when a pool has a water loss suspicion or there's water in the yard. There are some things that we commonly see as a result of that being there is under every suction grate or any penetration in the pool, there is a joint where the plaster or the pebble or the tile meets against that pipe. And it's very common for those to open up gaps. And sometimes they will even have the tape that they use to cover a screw hole on a frame and grate suction cover, or they may put tape around the skimmer opening when they did the shotcrete or the tile, and little pieces or remnants get left there and then get grouted over, and those degrade or they stick out and they create a pathway for the water to get out. So that's a very common thing that we see, that chasing water. I mean, that's like our never-ending battle, right? They always call the plumbers first. I feel like we're just constantly out there finding those kinds of issues. Error in the system, we get that phone call a lot. There's, especially with EDCs or big suction side vacuum vessels that are designed to trap debris, as you're bringing water into it in a 2.5 or even a 2-inch pipe. Now it reaches this large vessel, and it doesn't have enough vacuum, and there isn't enough friction in the water coming in, not enough velocity to pull that thing completely primed or look completely primed. So we get that phone call a lot. The way that we can check for it, if it's a plumbing thing or not, is you can reverse pressurize it and see if any water comes out of any cracks in any of the joints on the suction side. So you see if maybe you got some leak somewhere. It's a lot harder to find a leak on the suction side because it's under suction. It's not going to spray water out. It's going to suck air in, which is invisible. So we're chasing air in the system a lot. Pressurization is the main way that we go back and find out if that's a valid concern or not. And plugged lines. We get the phone call a lot. I don't think I have suction at my drain. I think I have something. I think a dog toy got sucked into the skimmer line or whatever it is. So we go out on those a lot. Those are the top 3 things that we're going out on pools that have water.
Right. And I hear you talk about getting that call a lot, like people think that they have a leak or something.
Right.
And I've heard you talk about the leakalizer and doing a bucket test. And I think those are all great things that service companies and builders should, kind of add to their arsenal. Can you talk to us a little bit about maybe the bucket test or, what that is exactly? Because I know there was a lot of pools that we had where people thought they had leaks and, we might send it to a leak detection company. But, I think it's a good practice in being more comfortable with at least figuring out that you do have a leak.
Right.
I think that is the thing that you would like to figure out at least, where it's like, yeah, well, after doing a bucket test, we can confirm that you do have a leak. We don't actually do that part of it, but that is part of the battle anyway.
Sure. So a bucket test is exactly what you said. It's the first step in figuring out, is my concern valid? Do I have a leak? Because people will think, maybe it's their first pool, they think their bill is high, or maybe there's a wet spot in the yard that quote unquote was never there before, or whatever. So their suspicion is raised. So step 1 is let's do a bucket test. Because what a bucket test is it's a very simple test to check and see if the pool is losing more water than evaporation. And you can direct a customer on how to do it. You can say, hey, look, here's a video on YouTube. Go check this out. Do this bucket test. All you need is a 5-gallon bucket and a Sharpie marker. And what you do is, and I'm going to dumb it down very basically here, but you fill the bucket with water to the same height height or a height close to that in the pool. You stick it on a top step, so half of the bucket's out, half is in. You mark the inside and outside of the bucket with your water lines, and then you wait 24 hours with the system off and the water leveler off, and you see if the bucket on the inside drops more or less than the outside. Those two, the bucket of water and the pool water height, should drop at the same rate, even though they're one's larger than the other. Evaporation affects them the same as a proportion to the surface area. So that's the first way. If that customer calls you after that 24 hours and they say, hey, bucket dropped 1/4 of an inch, pool dropped 3, okay, now we got something that we can come out and look at. If it doesn't drop, if they stay the same, but the customer says, I still think there's a leak, you direct them to do the same test, dump it out, start over again, but this time run the pump. That's a running bucket test. And that will generally show you if there's a broken pipe or a plumbing issue. The first one will give you an indication of whether you have a structural leak typically.
So when the equipment is running, if there is indeed like a crack or a leak in the line, is it going to leak faster? Because I would think that when it's just the equipment is off and it's just all the lines are at a stop and they're just holding water, that if it is leaking, it's going to be a little bit slower.
Right. That's exactly right. So under static pressure, under atmospheric pressure, the water inside the plumbing lines is under relatively very low pressure. When you fire the pump up, now it's under 10, 15, 20 pounds of pressure depending on the line. So it's going to leak much faster, exponentially faster.
Right. And you talked about, do you still use the legalizer?
Yeah, it seems like we go through periods where we'll use it a bunch and then we'll go 6 months without using it and we'll use it 12 times in a row. I don't know why it works out like that, but yeah, we do. And what's great about that is if a customer says, hey, I'm not in town, I can't do a bucket test, or I don't understand the bucket test, or I just don't want to do the bucket test, I'm mad at you, then you go out there with that legalizer and it's like a 15-minute version of a bucket test. So it allows you, and it'll give you data that you can print, tangible data that you can show to the customer. So there's definitely some, I think, you guys did some training on that, right?
Mm-hmm.
Yeah.
Yeah, with Anderson.
Yeah, it's pretty cool. So there's some parameters in there that you have to set and some things, but it's great because it's instant and you can get that result for the customer right on the spot. It's not a great idea, I think, if you go out, especially if you have an angry customer, to set a bucket test, because you just don't know what happens to that bucket after you leave. You know what I mean? So I think it's important to see with your own eyes too.
Right. And I just talking about
They just fill the whole bucket up with water.
Yeah, they just start bucketing it out of the pool.
Sorry.
Or they get it wrong and they fill the bucket up to the top. My bucket filled up. I don't know what this thing's leaking.
Speaking about leaks, you're talking about the bucket test and the legalizer.
Mm-hmm.
Something I don't think that we touched on was to make sure to turn, if they do have an autofill, to shut that off.
Right.
For anybody that's new, that's just automatically feeding water to the pool. So if you are doing a test, you want to make sure that that is off, because if there is a leak, that thing is just constantly going to be running and you're not going to see any kind of results.
Yeah. And rain, if it rains, or a sprinkler or something goes in the pool.
If you're in Arizona, that's bad timing.
Yeah, that is bad timing.
It's like, did you really try it today?
Well, the autofill is a good way to indicate, if you hear that thing constantly running, that's also an indicator that it probably has a leak. If the autofill and float valve is working properly.
I was going to say a lot of times.
But there is a water leveler on the market that will run almost all day. Paralevel. If you own a Paralevel like I do, or if you have a customer who ever calls and they're like, my Paralevel runs all day, those things give out the least amount of water. They will run like 18 hours out of the day. I've checked my pool multiple times. I've checked the line just to confirm, but having owned one, I will tell you it will make you crazy.
What do
Is
those
that
look
Paramount?
Yeah, that's Paramounts. They look
The click?
totally different. Yeah, it's got the gray top and you rotate it around the stem. Is that Kyle's favorite?
We were working on one the other day, and I was like, "Do you remember what this thing's called?"
Yeah,
because I saw it and I can't remember the name of it. But
it's
I actually like those. Do they have any type of sensors or anything built inside of them?
no, they work like a corky. They
Yep.
just like pop down.
proprietary float. But yeah, so those things run all day. But you're right. If somebody else had a regular water level and it ran all day, then that's a problem.
If you have a flip and float
Yeah.
or a corky,
Yeah.
and they're running all day, then it's a good indicator.
For sure. For sure.
Are you saying that like in a bad way, or
What, the
like that they're
Paralevel?
running all day, the Paralevel?
No, I was just saying it because I said it was an indicator maybe that has a leak, but
Yeah.
It may not be if you have
a paralevel.
Because a paralevel, you can't really hear it.
If you get close to it, you can hear it.
Okay.
But
Because I felt like those are like more like surrounded. They're like more embedded into the actual.
Yeah,
they are.
They're in like a much smaller container too.
But it's amazing how people turn into Sherlock Holmes when they think they have a leak, man. It's crazy. And the next thing you know, they're going to read the manual. They're going to be online. They're going to tell you how that, they're going to time it. They're going to put cameras on it. So it's crazy.
Cameras on it.
Yeah.
I stayed home from work this whole week.
Exactly. I marked this with seismic tape on the tile line and crazy stuff.
Why'd you do all that?
Oh, that's awesome.
Since we're talking about plumbing today, and Justin talked about them on the episode already, we have to mention the top quality pressure testing equipment from Anderson Manufacturing. Anderson's system is built around their popular straight-sided test plugs, which come in a large variety of sizes and styles to fit all kinds of plumbing configurations. Most plug styles feature heavy-duty brass hardware and large, easy-to-turn wing nuts that will last through years of heavy use. Induce pressure using a low-profile Anderson pressure tester, which uses a versatile quick connect coupling system with open stem inducer plugs. Outfit your truck today with one of Anderson's preset pressure testing kits or purchase pieces individually to fit your specific job. Whether you're testing the plumbing on a new build or trying to pinpoint a plumbing leak, you can trust Anderson equipment to get the job done safely and efficiently. Use the promo code POOLCHASERS at checkout to receive a free LeakMaster repair product with your next order on leaktools.com. And don't forget to check out episode 87 of the podcast to hear the story of how Anderson Manufacturing actually started as a car radiator test plug manufacturer over 70 years ago.
As these pools are being built, they're getting crazier and crazier every day. And remember when we used to do pool service bids, we would be looking at these equipment sets and they would be extremely intimidating because there would be, 4 or 5 pumps and 3 or 4 filters and maybe a couple heaters. And there's just plumbing in every direction. What is the best way, somebody doing a bid or just looking at that equipment set for the first time, the best way to really assess all the equipment and figuring out what does what and seeing if there are actually maybe any problems with it? But how would you go through it?
So if I get called to a job that we didn't do the plumbing on, our company didn't, here's what I do, okay? And this is going to save you a ton of time, okay? I'm going to break it down. Grab a piece of paper, you draw the equipment set just like it sits. So you would draw your little icon for a pump, filter, heater, and then you're going to draw just on the front each pipe as it comes in. It doesn't have to be a great drawing, but just draw every pipe. So basically you have like on a piece of paper your equipment and all the pipes. And then you shut everything off and you just start from left and you go to right, one by one. So you'll turn on pump 1. If it's got 3 pipes on it, you're going to close the valves. You're going to run them one at a time. You got to use some common sense. Anything that's a suction, you just turn on the pump, you open one suction line, you walk to the pool and see what it is. As you identify a line, you mark it. And anything you can't get, if it's not obvious, just skip it. And you just go left to right until you have everything marked or as much as you can. When you get to the end, if there's anything that you couldn't mark, that you couldn't find, you just walk out to the pool and you go, what didn't I see run? Well, I didn't see this deck jet run. Where could that be? And then maybe you figure out that there's a valve box somewhere and the valve is closed or whatever. But it's process of elimination, and it's just important to start from left to right methodically, one thing at a time, and just look for the obvious stuff. Don't try and overwhelm your stuff. Don't get stuck. I can't figure out what this one is. Just keep going. Get until you get them all. And then sometimes it's very easy at the end. You go, well, I'm looking at this piece of paper. Everything is accounted for except for a Venturi skimmer, and I have one 1-inch line that's not marked. That must be Venturi skimmer. Let me go back and check. Oh, Venturi was plugged. That's why I didn't see any flow. Now you know what that is. The other thing you can do, which is really helpful, I would recommend this to more of the professional guys, is to get a CO2 tank. And you can see if the pool has water. If you are able to pump CO2 through it, you can see it right away. I will say be super careful. You can end up in a hospital really quick, especially if the line is plugged. We're professionals. We do it all the time. But CO2 is another huge thing to help with identifying plumbing lines. We also go out on a lot where a pool will get half built and there's no equipment set yet. And it's just a stack of pipes and you have to figure out what they are. So I use the same system. I draw on a piece of paper. I go, here's everything that's in the pool. I got 2 grates, a skimmer, and then I mark what pipes I have, and I just start matching them up, cut everything and match them up.
Dude, I seriously love that. And I never even thought of it, but I would definitely do that and almost do my best to like draw out the pool, because as you're doing it, you say you turn on this feature and you know it's that pump, you could kind of like, okay, mark that feature even if you don't know the terminology for that.
Sure.
And you can kind of match it where it's like, okay, this is one, it's right here on the pool that I drew, and then this is where it's out on the pump. And now I can label it correctly later on, or you can do it there on the spot, but just matching it, because it's crazy. Even if that took you an hour or however long it could take you to do that, I mean, really going above and beyond and figuring that out, it's crazy how much easier that's going to make your life and your team's life in the future, because everybody has an understanding of what does what and what this plumbing does and what this pump does and what this filter does. And it's so much easier when the customer calls even and they're asking questions about stuff.
Yep.
I really like that. Thank you very much. We're going to have to work on that. I saw, it just reminded me, you had like a diagram next to one of your equipment pads.
Yeah.
I thought that was like super cool.
Yeah.
And just like breaking that down. That's what reminded me of it.
Yep. That's a schematic that we drew in-house, and that was to show how our plumbers brought it to life. It's almost exact.
It's pretty cool.
Yeah.
I like that. But I think also when you're saying that, what you said earlier, like the suction side is going to be in front of the pump.
Right.
The return side is going to be after the filter. If you remember that most of the time,
Yeah.
it makes that diagnosing quite a lot easier, where it's like, all right, well,
Absolutely.
these have to be suction and these have to be return. That's how I usually start. All right, I know all of these are suction and these are all return, so let me just start playing. And like you said, and it's good going one at a time, but if you remember that, it saves you a lot of time. You're like, no, that can't be a suction line.
Yeah.
It's over here,
And I see guys get overwhelmed because they like get to stuck, and the key is just get as many as you can out of the way. Anything you're stuck on, just skip it, so you don't get overwhelmed in your brain. Just do what you know and then fill in the pieces.
Yeah. And so besides that, what issues are you looking for? So if you're like fully almost assessing this, where you might have some cavitation issues or different things like that, what are things that you might see during an assessment that you're going to want to make a note of, because it's probably going to be some type of repair that you're going to make?
So we're looking for, in terms of cavitation to start, we're looking for not enough distance between the first elbow or fitting in front of a pump and the pump. We're looking for downsized plumbing lines, like that are maybe downsized where they shouldn't be, making sure nobody did anything wonky on the equipment, making sure that heaters that need bypasses have bypasses. You can strip the copper right out of a heater if you feed it more than 8 feet per second. So you got to make sure that any heater that can't support the flow demand of that system is bypassed. Same thing with IntelliChlors. Some require bypasses, so you're looking for that. Making sure if you have a UV that it's plumbed before a heater. We have a whole checklist of things that we go through and make sure that everything is installed right. I would say what I just mentioned, those are probably the most common that we see. Or the other thing is, maybe a bypass valved incorrectly, a heater getting too low of flow or something like that. Those are the things that we're looking for, like, straight away.
Right. And what are some good practices for even adding a new pump, since we're on this topic? Because, you were just talking about that distance between pump and that first elbow, and you probably need a good amount of distance because it's that velocity that you're talking about, and you're trying to make it as fluid flowing as possible. Right.
Yeah. So I'll touch on that for a second and not getting too like heady or hydraulic-y, but so you want 5 times the suction diameter in front of the pump. And what that means is if the pump inlet is 2 inch, you want 5 times that 2 inch of straight pipe. So you want 5 times 2, it's 10. If you're using a XF pump, that's a 2.5 inch inlet times 5. So 5 times 2.5. That's how much straight pipe you want. And what that's doing is water that moves through a plumbing system is subjected to pressures. Okay, so when water is under very low pressure, it's moving very quickly. So that it's under very low pressure. When it reaches a low pressure, it vaporizes and very tiny air bubbles appear. So when that happens, that's when you get cavitation. When the pressure drops so low that it strips that gas out of it, basically. So when you have that piece of straight pipe, what it's doing is it's collecting all the water, it's removing any turbulence, and it's uniformly bringing that velocity into the pump basket and the volute of the pump. So that's why you do that, and that's why it's important. If you have a 90 that's right before it, the water makes that turn at the 90, it's subjected to a ton of force right there. It might reach that pressure point where it'll vaporize and you'll get air bubbles in your basket that you can never get rid of, or the pump will be loud. It also affects the performance of the pump, obviously. So, but here's my tip to anybody replacing a pump that I think will help you is don't cut before and after the pump, especially not if you're doing, let's say you're taking out a TriStar and you're putting in an IntelliFlow. No offense to Hayward, it could be the other way around. Whatever. If the volutes don't line up or you don't have the bottom, try and pick a point to start. For example, a pump. Don't start at the three-way valve. Start at the ground. Cut down at the ground with couplings and repipe from there up. What that allows you to do is you don't have to fight or add 290s in front of the pump on a suction or double 45 or have a bunch of couplings. Pick that point and start. It's going to make your job easier. It's going to have a brand new three-way on the front. You're going to have a perfect alignment on the inlet. Same thing on the outlet. Coming out of the outlet, don't just cut 6 inches higher and then try and line that back up with the new pump, or cut maybe halfway between the filter and the pump. Replace the top pump union. Start fresh from that union. You can always tell, us pool plumbers can always tell when the service guys have been out there. You know why? Because there's couplings are everywhere. There's a street 90 into a coupling. That's a dead giveaway. Whenever I see that on the high side of a pump, it just means somebody cut it right at the 90 and did street 90 coupling right into it. So try and pick your point to start and stop so that you're basically replacing like an entire zone or an entire section. It's going to make your life much easier.
And how far down would you recommend somebody digging? Because I'm thinking of my pool, for instance, where the space is really tight. Mm-hmm. And when they put all new equipment in, it was really difficult in having that room from the pump to the first fitting.
Yeah, there's a lot of times you can't get that 5 times in front. And unfortunately, like, you know, especially here in Arizona where it's go, go, go and less like let's do it right, that runs into it. But you should cut. What I do, I try and cut down so that ideally the coupling that you put on the legs coming out of the ground is below dirt, so you can't see it. So it looks like just fresh pipe coming out. Can't always do that. It depends on the water level in the pool. I'll cut those pipes in front, you know, maybe 6 inches higher than dirt, and then look down in them and see where the water height is when the water's static. That, because if you go too low, you might cut below pool water level, and now you just created a swimming pool with the equipment. So if you cut them, look down in there, and then you can get your couplings ideally below dirt. That's the best place to go. And at that same time, if you needed to move that suction manifold out a little to get your 5 times, you could do that. So
very good.
Yeah.
What do you do in case where there's like cement? You know, your guys are coming straight up out of cement. And what would you recommend then? Because if you put a coupling close to the cement, you don't have another cut. You know, if you need it.
Yeah, so that's right. There's cases that you can. I mean, sometimes you can chip around it and do a coupling in it, but that's a lot of work. I mean, I don't think from a service guy, you would cut it as close as you could and then coupling back up.
Yeah. But then you got no extra cuts after that. You got to start breaking concrete.
Yeah.
But yeah, it's definitely much better to rebuild like the header so that you get straight in instead of makeshift.
Yeah.
But like there's not always any room, man. Like you said, sometimes you're just so small of equipment pads and somebody else has been there before you, and you got, you know, there's already 3 couplings in the way. So
I never let like the inconvenience of a tight equipment set, I never let that inconvenience make me do something stupid in plumbing. You know what I mean? Like if it's so tight that I have to do a double 90 right into the front of a pump, just don't do it. Make your customer replace that suction 3-way. Like, you know, it's your name on the job. It's your warranty. You know, you don't want to have somebody go behind you and post it on Pool Nation or wherever they post this thing. Hashtag plumbing
Pool
fails.
Nation.
You know what I mean? So, or wherever it is that they're posting all the bad pictures.
End up on the news, man.
Yeah.
I just saw myself, dude. They just shared it again on the news.
You saw yourself on the news?
On Facebook. Yeah, the one where I belly flop right into the pool when we hit like 116.
They did it again?
I got to read all the comments about, the dude didn't commit right at the last right at the last second, his knee bent. I'm like, fuck you, man. Get a life. You watch this really in slow motion?
So
like,
funny.
goodness gracious.
That sucks. That totally sucks.
That's pool nation for you right there.
Damn it.
So if you're going to take on the role of plumbing at any degree, what are all the tools and supplies, equipment? What do you need to have on your vehicle at all times?
All right. So these are tools that I think if you had these 5 tools, it's actually 6 tools on your truck, you could pretty much get anything done. So these are the tools you would need. You would need a set of pipe cutters, a reciprocating saw, a hacksaw blade, chip and peel tools, which is I use a Klein pliers and a flat blade screwdriver, and a bonus if you have an inside cutter. If you had all that on your truck, obviously glue, you would need that too, but if you had those 5 hand tools on your truck, you're set.
You're good to go.
Yeah, because you got cutters to cut your pipe up to 2 inch. You got a reciprocating saw to cut in a weird spot. A hacksaw blade, just the hacksaw blade, not on a hacksaw with a glove, will do wonders. Like plumbers, any guys out there doing repairs, man, all over it. Chip and peel, you need to know how to chip and peel. If you can't chip and peel, stop what you're doing right now and have somebody teach you. Go watch, call me, I'll teach you how to do it, whatever.
What is that exactly?
Chip and peel? So chip and peel is...
Sounds delicious.
It is. So it's a Lay's potato chip, an avocado. No, it's let's say you want to remove a fitting, like you want to take a coupling off and start with a brand new coupling. So you cut the coupling in half, and then you cut a slice in it down to the pipe only through the fitting, and then you can take and tap a flathead screwdriver under it and basically peel it off the pipe. It's kind of like shelling it, basically, like you would shell a nut.
For sure.
Yeah, it takes some skill. But chipping and peeling is, I can't tell you, it's one of those things in plumbing that you absolutely have to know how to do.
And what do you think about we were trying to figure out the name of this, and I can't remember where you're actually, it's the drill. It's
Ram bit.
Ram bit. Yeah. What do you think about that?
I used to have a set. The problem you run into is if you don't drive it in straight, your plumbing will come out kind of wacky. And the way plumbing is designed, it's called interference fit. Are you familiar with that? Mm-mm. Okay, so the way interference fit works and the way that all of the plumbing fittings that we actually work are inside the fitting, there's a ridge, and your pipe meets that ridge. The strength of that glue joint is that where it meets that ridge and where the glue fills that void. A lot less of that joint depends on all the glue around the pipe inside the socket. It's mostly at that interference fit. And that's why you bevel pipe, and that's why you want to cut it really straight. You want that pipe, when it slides into the fitting, you want it to hit that ridge, the interference fit, and create a seal right there. Because if water can't get past that seal, it can't get around the pipe in the joint. That's the point where it's the most strength. When you use a ram bit, guess what comes out? You will ram right past that, and you have no more interference fit. And it's just, you're just jamming it in there and filling the void with cement. So you got to really know what you're doing.
Very good. Thank you. So you talked about the tools. What are some of the other supplies that you're going to need to keep on your vehicle?
Definitely pipe fittings and glue. No brainer there.
What fittings?
Everything. So 90s, 45s, T's, reducers. You know, there's probably 40 fittings that I keep in stock on my trailer that I have when I plumbed or when I do go plumb here and there.
What are some of the most common sizes? Like what is there?
2 inch is the most common size if you're doing in-floor systems because they're built out of 2 inch. 2 inch is the biggest demand on supplies out of your truck. That's where you use the most pipe and fittings in general. Next would be the trench. But the most common sizes that we see are 2 inch through 3 inch. That's the most common. Pretty much every job has those. You get some 3/4 in there for water levelers too.
What's your thought on like sweep 90s versus, using bigger pipe, like 3 inch?
Yeah, all day long, I would upgrade over a sweep. I know that that's probably not going to be a popular statement, and there's probably going to be people out there that disagree with that. But I keep this study in my binder that I have, my Holy Grail binder that I keep with all my hydraulic info. Lasco did a big study when California came out with that sweeps. The advantage of going to just a different size pipe, and what you're doing there is you're just slowing the velocity down of the water. So if you take the same amount of water and move it through one pipe size bigger, you're slowing down the velocity. There's less friction loss inherently in now. What a sweep does is it's just taking out the head loss in that fitting. But it's so minimal, and they look like crap, I think. To me, it looks like a customer went to Home Depot and bought all the sewage fittings that they had, and they're trying to make like the sewer drainage stuff work. So I hate it, but I don't know. I it's better than not using them, I guess. I hope it doesn't eventually turn. I think it will. We'll eventually be all sweeps here, but they're astronomically more expensive. They're 5 times the cost of a regular fitting because they're just not as popular or not as used.
Well, this might be a dumb question, but for service companies anyway, how are you gonna do that? If it's 2-inch plumbing, like how are you gonna change 2-inch to 3-inch?
Yeah, so I don't know that it would be worth the effort.
Or are you talking more for like
I'm
builders?
talking new construction.
Okay,
yeah,
okay,
yeah,
okay.
like from the ground up. Yeah.
So sweeps are like, would you do that if that were your only choice?
So if let's say you had an equipment set and you're a service guy and you're like, I want this thing to be more efficient, and you change them all to sweeps, I challenge you to do the math on that and see what the actual gain is. It's so minimal. Remember that plumbing and fittings is a minor loss. Okay, it's a minor loss. It takes 100 feet of pipe or more to even equal what the exit and entry loss is on a plumbing line in a pool. So give you an example. Okay, so you have a suction cover. As water passes through that suction cover, there's restriction. It's generally on a normal suction cover, it's 2 feet ahead. So to add up enough fittings to get to 2 feet ahead, 190 is equivalent to 6 feet of pipe. 100 feet of pipe is 4 feet ahead. So that suction grade is 2 feet ahead. If you divide 6 by 100 and multiply it out, I mean, it's like you're fighting, you're doing all this crazy stuff. You're putting all this sweeps, all that effort you go through. And that's not worth it, in my opinion. Yeah. If you can do the whole system, maybe, but.
Have you looked at the statistics on like each sweep I've seen in an Instagram post is usually about 20 to 30 likes. Mm-hmm. So the more sweeps you have, I think the more interaction you're
really
going to get.
Great. I do notice a lot of people comment when I put the sweeps up there.
Someone's sweeping today.
Somebody's sweeping.
I think it does, isn't it? It's a little higher though too, right? So in some cases you can get that little gap of if your pump is like, a half inch, you can get that gap by using a sweep. So that I think that helps somewhat in the.
That's true.
Like with Jandy, I think because that's what they give you. I think is like a sweep,
right?
90 that comes with it. And I think that's what it's for, is to like make that height difference without having to rebuild a header or something.
Yeah.
So you can get a little height out of them, but if you need it,
I say just build these systems at 4 to 6 feet per second, man, and throw these sweeps away. That's what I say. It looks so much cleaner and better, in my opinion. Whatever that's worth.
Back to the supplies a little bit. There's a couple things that we didn't touch on, where like our guys usually had shop towels and different colors paint and different things like that, or even always had like a box cutter razor blade, kind of like to get the edge of the plumbing to make sure that a sandpaper, different things like that. Are those all things that you recommend as well?
I would say yes, I do recommend them. I would say in general the guys don't carry that. Service guys for sure, but the average pool that we're plumbing, there's probably 500 glue joints on an average pool. So can you imagine sanding 500 edges? That's why, sadly, we should bevel every single fitting, but we don't. I mean, it's, and the reason we don't is because after years and years and years of installing these, the failure rate from the joint failing because the glue got pushed out from a flat edge or whatever is low. But
I'm surprised they don't have like a drill that has like sandpaper over it that you could just put one inside and it sands it, and then one that goes over the top and sands it.
They make that for copper. They make a product called Bevel Pro. It doesn't sand it, but it takes the edge off. Bevel Pro does.
Oh, and that's all you're really looking to do, right?
Yeah, bevel it. Yeah, beveling allows it to get to that interference fit and then have a little groove for the glue. And when the pipe is beveled and you push it into a fitting, if it's beveled, it'll ride on top of the glue. If it's flat, it can sometimes squeegee all the glue right out of the fitting.
Right. And you probably have a different team that actually is doing the equipment on top, because I'm sure obviously you're not painting plumbing that is about to be buried.
We do.
But you paint even underneath?
No, not underneath.
Yeah, sorry. I'm saying you don't paint the stuff underneath, but the stuff on top, whoever's doing that, do they just have kind of like a bunch of different colors of paint, because I noticed that you don't do very much Hayward, but when you did, I saw it was like really
Gray.
nice. It painted it gray, and then obviously, Pentair has its own color.
Yeah, it's actually Hayward Taupe.
It has its own name?
Yeah,
Yes.
Hayward Taupe.
And Pentair's almond.
Yeah, Pentair almond.
I never got that Crayola. Oh, what is this? The Crayola taupe.
So what is your thought on painting the pipes? Because that's big here in Arizona. But
Yeah.
I know like a lot of times you'll see on social media people don't agree with that or don't understand it.
Yeah, I'm a huge paint advocate, I'd say. The plumbing gets pretty crispy pretty quick. There's a layer on the outside of PVC that's designed to prevent oil from penetrating it, and that's what turns colors like right away, and it becomes brittle. So I think you got to paint it. It looks clean. It makes the handles pop on the three-ways and stuff. You can really see them because we generally take those off and paint everything and then put them back on. So I say paint it all day long. If it's indoors, like a big commercial equipment set, don't paint it, because you want to be able to service that equipment if it's painted. There are some cases where you got to paint it for identification. You might paint, a pool system blue and a spa red or whatever. But if you don't need to do that, if it's not that complicated of a system, it makes the repair so much easier. Doing a repair on something that's painted, now you got to, sand all the paint off, and that's a pain in the ass. But I say outdoors, paint it all day.
Dude, you're a professional. When I see plumbing that's not painted, it just looks like shit. But it also looks like something a homeowner would do.
Yeah.
You know what I mean? Like, they wouldn't take the time to do that, but...
Then imagine purple primer and gray.
That's what I'm saying. Yeah.
just dripping down the side.
Nightmare.
Oh, yeah. So freaking ugly.
Yeah, so I use the clear stuff, huh?
Yeah, or that the blue glue, the service guy blue glue. They should stop selling Christie's.
Stop selling Christie's. Christie's is definitely an indicator of a homeowner.
Yeah.
And what do you recommend for organizing all this stuff?
Mm-hmm.
Is there anything that you found that worked really well? I've seen other people, like someone recently had a really nice Milwaukee drawer set stackable deal, and he said that it's cool until you try to close the top of
that was my boy Drew. That was Drew.
But it makes sense. It's clean, but if that's not going in the back seat of your truck, it could be difficult.
Yeah, that was such a bummer, because I bought, what sucks is I bought all of those boxes, like a kit of 12. Okay, fully committed, loaded them with everything. They are heavy as hell. Get ready to throw it in my truck, throw it in the back of my truck, and I realized that even with the handle telescoped down, I can't close my bed cover, so you can't lock it. So why even have your tools back there? That was such a bummer, man.
That does suck.
That's such a bummer.
So what do you recommend? I don't know if you thought much about it, because you don't obviously clean pools, but people that need to keep a lot of these fittings and tools and things like that on them for the most part of their day, what do you recommend for getting organized with it? Uline
has a divider box. These things are freaking great. You can buy them in any size. They're plastic, they're heavy duty plastic, and they have movable dividers, and they're stackable. Dude, those things are crazy. They also sell milk crates. Milk crates are good too, because you can see through them. You can kind of see your inventory. But for smaller parts, hit Uline up, storage bins, you'll be like absolutely set. But it's all about being able to stack them, because when you get everything in the back of your truck, then all of a sudden you got to put a filter in there. You need to be stacking them up, and then when you're done, you lay them back down. I would say that's the best luck that I've had. And something that you can carry to the backyard, I always found that to be such a pain in the ass when you're just carrying just these boxes of miscellaneous you gotta
shit.
roll your shirt up like that and load your shirt.
I remember Danon yelling at hey, can you go grab this from the truck? And I'm just like, shit. You want a trick for carrying a lot of fittings in the back? What? You want a trick? Yes. A string. Oh, there you go. Yeah, you stick a string through it. On the end of the string, you just have like a piece of something, and then you just feed them over the string, and now you got a candy necklace. Like a candy necklace, exactly. Yeah. Such a fat ass. Everything I listen to, I haven't had breakfast yet, man. Oh shit. Oh, a chipping wedge, or what would you call it? Yeah. Like most people think of these plumbing references more sexual, but Greg thinks of more food. That's great. Candy necklace. What are you, fucking kid? Yeah. But anyway, yeah, candy necklace. Yeah. That's a good tip. You can't eat it, so. Yeah. I don't know if there's anything that you think that we missed out on that. So we're talking about glue, primer, all the different fittings, obviously having enough straight pipe, different sizes.
Torch.
Torch?
Yeah, we heat bend.
Okay.
Which, as long as you're not in commercial, you can heat bend. That's huge. Have you ever seen anybody heat bend pipe with a big propane torch?
I don't
I've seen it.
think so.
I've seen like one time in person, but
Yeah.
Maybe on YouTube or something, but not. How does that work exactly?
It's a weed burner head or an asphalt burner, and they use them to heat up asphalt to mold it or to burn weeds. So you have a propane tank with a lead, and then you have your torch. It's basically like a big blowtorch, and you can heat the pipe up. Makes it malleable, makes it like a noodle. You just don't heat the ends because, the ends go out around, you're screwed. So you heat up to like a couple inches of the ends.
And that doesn't affect
and you can
the
bend
plumbing?
the pipe.
Mm-hmm. It doesn't. If you read the manual from Crestline, it'll say to do it in an oven and to fill it with sand so it doesn't lose form and stuff. But for years and years and years and years, since I started in this, we've been doing it.
You know where we did see that is at Pentair when we saw the electric heat pumps.
Yeah.
They had like template
Arches.
Yes, arches.
Yeah.
That's what, and I think they were doing. I didn't see it. We didn't see it like actually be done, but
Yeah, you're right.
There was. I was like, man, I think I've heard of that somewhere. That's
Yeah.
cool, but it doesn't affect the. You're talking about just regular PVC. You can heat it up and bend it the way you want it.
You can definitely burn it. You got to know what you're doing. You can apply the heat in one area too long, it'll brown it, and then you got to chuck it. But yeah, if I did one for you, it would be perfect. You wouldn't even know I heat bent it, other than it'd be obviously radiused.
And why would you need that?
That sounds like a challenge.
Yeah. Well, if you had,
You said it'd be perfect.
yeah, I'll do it. No, it's if you had a round spa, for example, and you needed to do a loop for an airline. Well, you could do it with 845s, or you could do it with one heat bent piece of pipe. So there's a lot of instances you can use it. If you have a free form pool and you're going to follow the contour, if you do it with fittings, you got to kind of make straight runs and then get close, but you can't do a free form with pipe. So it just to make it easier.
What is PVC made out of?
Polyvinyl chloride. It's resin that they melt and then extrude into a pipe.
Is that why you can do that? Is because its normal state? It's like you're taking it back to its normal state.
Yeah, it's because what it's made of. I mean, I'm not a physicist or whatever it is that would know that exactly, but yeah, you can heat it up and just like when it was born, if that's the right way to say that, when it was created, it becomes malleable again.
I love that. That was good.
Thanks.
It's just a little baby.
It's just a little baby
New in the
PVC.
world. Good.
Yeah.
Yeah, I think we can move on from the tools and supplies. I think that was all really good, very helpful.
Yeah, for sure.
Ledge Lounger has done it again. Their new signature bar stool might be one of my favorite products yet.
Why is that?
I thought you'd never ask. Imagine you're hosting a get-together barbecue with friends and family, and the music is bumping, the carne asada is sizzling. Things are going great for sound and smell anyway, but all of a sudden, some of the people want to move their conversation to the pool, but there's no comfortable sitting in the pool.
Well, that's where Ledge Lounger has you covered. Their new signature bar stool comes in 2 different sizes, bar height and counter height. The way these work is simple. You can sit on the deck or wherever you want, and when you're ready to sit in the pool, you just toss it in. The self-sinking technology will drop the seat to the pool floor in just minutes. And best of all, when it comes to Ledge Lounger, you know you're getting a quality product that looks great, is backed by an awesome warranty, and of course, comes in a variety of colors.
And one of the most beneficial parts is that any type of pool and any type of business can sell. You can be a builder or a service company. It's that easy.
Absolutely. So you can learn more by going to ledgeloungers.com or clicking the link we provided below.
Well, sometimes in plumbing, we see that it's not level with the pool. It'll be above grade or below grade. Can you kind of explain what that is and some best practices for plumbing both and then working on both?
For sure. So 2 scenarios. So when the equipment is higher than the pool level, that's called suction lift. When it's below, that's called flooded suction. Suction lift, what you want to do is you want to combat the water dropping back down to water height. Water seeks its own level whenever there's not vacuum. So if you were to open a pump lid on the system when it's turned off, it's going to release the vacuum that's in the system, and all the water is going to run down. It's going to be really hard to prime the pump. So what we do is we install check valves on the suction lines. Check valves only allow water to move one way, and then they close when the system shuts off so it won't go backwards. The best practice for that is installing the check valves closer to the pool instead of in front of the pump. If you install them in front of the pump, when you fill the pump up with water, the line doesn't fill up with water. So you have to do it once, do it twice, do it 3 times until it finally primes. It could take a half hour, hour and a half. If you locate them out by the pool, every time you prime it, ideally that once you prime it the first time it stays full, but if not, you could fill the whole line up all the way to the check valve. You have all of that water to make it to the pump so that it can pull itself primed. Another trick we do on suction lift is we put the suction check valve somewhere serviceable down in the landscape close to the pool, and we put a hose bib. We tap in a hose bib on the suction side. Then you can hook a garden hose right to it with a female-to-female coupler, and you can open water pressure at the same time that you're priming the pump and pick up prime right away. That's a good trick.
When is it considered suction lift? Like, even if it's barely, just,
The eye of the pump is called the volute. When the water level that's drawing from is below the volute. So technically, every pool that you've probably seen is suction lift, but it's so minimal that there's no provision needed.
Okay.
Usually you hit
I think that's what I was getting at, is if it's just barely a foot or something, is it that big of a deal?
Yeah, no. I'd say you start to see the problem probably when it's plus 12 and up.
Okay.
The greater you get, the more of a problem. You probably don't need a check valve on plus 12, but you'll probably fight it. It'll probably take a while to prime.
But if you had a spa that was higher, you're definitely going to want like a check valve and all those different things.
So that moves us into flooded suction. So flooded suction is when it's higher, like on a spa, or if your equipment is below grade. So what you do on a flooded suction is you want to prevent that water from moving into your pump basket when you open it. So we put shutoffs, we call them service valves, on every line. You got to put them on every single line. And you want to put them down line like, on the front of a pump, you'll have a 3-way valve, right? You want to put those 2 ways between that 3-way and the pool so that you can service the 3-way. If you put them between the 3-way and the pump, you can get to your pump basket, but you can't service the O-ring in your 3-way. So you want to put those on the lines between the control valves and the pool. Same thing on the return side. You want to put a service valve last in line before the plumbing leaves the room and after a check valve or anything else that's serviceable. And if you have shutoffs on all the inlets and all the outlets, when the pool is higher, when it comes time to service the equipment, you close them all off. Now you can open the the baskets, you can open the filter and service everything without the pool ending up in your face. The other thing that you do is if you have a cartridge filter and you're in a flooded suction is you have to put a filter drain on, because if you shut everything off, that plumbing system is probably holding 200, 300, 400 gallons of water. And if you open your cartridge filter, it's going to end up in your lap because there was nowhere for it to drain. In a normal pool, you can open the air bleed, and you hear all the water in the cartridge filter run out. Well, it's not like that when your water's above your head and you're closing everything. So what we do on the outlet of the pump, we put a T in a 2-way valve or a T in a ball valve. That way, once you close everything off, you open your air bleeder and you open that valve and all the water will run out in that portion of the plumbing that you have isolated. Now you can take it off and work on it. The other really important thing that I think people miss a lot, and us included, is you need to switch your heaters to flow switches because they're pressure switch operated in general. And when you're below water level, it'll sense pressure even if there's no flow in the system. So you got to make sure that you're bypassing pressure switches and you're doing flow switches. If you have ozonators, which they're open to atmosphere, you want those to be on Mazzy injectors instead of suction ports. So those are the provisions for a suction, flooded suction.
Right. And what are some things you want to make sure that you have on your vehicle at all times? Because, you get stuck up in an area where there's no pool supply store or it's on the weekend, something's closed, whatever it may be. But what are some things you really want to have on your vehicle in case you run into a situation where you've got water falling out uncontrollably, where it'll stop, but probably not till the pool's empty?
Yeah, which is not ideal, right?
It'll stop eventually.
I'm gonna sit out front in the truck while this happens. Keep rubber plugs. Worst case scenario, let's say you cut into something, you're screwed. You made a mistake. You can throw a rubber plug in it. There's very little pressure on the line unless you're very, very far under water level. So you can stop it with your hand usually, like in a panic moment. You put your hand over the pipe, it'll stop the flow. If you had a rubber plug on, you just jam it in there until you can come up with a game plan on what to do. The same thing if you're the type of person who solders. You always keep a little bit of bread on you, or you keep, they make plugs that go inside in case you get into a situation where you can't stop water flow. I think that's one of those things you got to have plugs on you of some sort just to prevent that, because it's definitely, that's the scariest thing that can happen is you end up cutting something or pulling a check valve faceplate off and then realizing you got a whole waterfall coming down at you.
Right. So you would just get like miscellaneous sizes in the plugs, like you get like 2-inch, 3-inch.
Yep. You can get 3/4 through, and 3/4 their cone. If you go to Anderson, if you go to Leak Tools, not to give them a free plug or anything, but we use them, they have plug kits.
They're a sponsor, so it's okay.
Dude, I love them. Mm-hmm. They're my favorite. If only I got a free plug kit every now and then for plugging them, that'd be great. But no, they have plug kits, so you can get like an assorted size in a little bin.
Oh wow, that's super cool.
Yeah, and then you just carry that sucker with you, and you're good to go.
And it doesn't push it out or anything like that. It works pretty good.
Yeah, they have the test hooks, so you just put those suckers in, tighten them down. Like I said, it's only under whatever atmospheric pressure is at that height. So,
I think what I've noticed, and I think what you were probably getting at is, in the cases where they don't provide shutoff valves and the water is constantly running with pumps, like if you hold brand new O-rings with you, most of the time you can put a brand new O-ring on the lid and get it to shut and stop. Yeah. If it's an older O-ring, it's going to pop out and get stuck. And if you have a brand new one with you, if you carry like pump lid O-rings all the time, then you can put a new one on and kind of stop that flow.
Yep.
But that's if they didn't plumb in correctly.
Yeah. There's a trick too to a three-way. Are you familiar with how to reverse a three-way?
Yeah.
Over the stop? Yeah, you could do that too. We run into that. Yeah,
so you take the top of the screw off, like slide it up a little bit, and then you can close off the one line that's directly in front of the pump. That way it will stop the flow. But even then, if they didn't do it on the return side, you still got some water flowing. But
yeah,
you can shut off a three-way too by like turning the stop to the suction side in front of the pump.
Yeah.
But you gotta unscrew it and lift it up a little bit to slide it.
To get it over the stop.
Yeah.
Did I hear somebody say something about using balloons or something like that?
You can.
Yeah, you can use balloons.
Just the key is to fill it with a little bit of water, not just air. Gotta have a little bit of water in it. Yeah. If you try and do it with just air, it'll probably pop. I mean, I'm sure you can get it done, but if you fill it with a little bit of water and air, it's like a dream.
And then what would you do in that case? You
turn that pump on. Just turn the pump on.
Just turn it on.
Pops and comes right in.
Oh yeah.
Yeah. Don't do it on the return side. Try and get it out somewhere. Don't let it go to like the 6-port.
Yeah.
But
interesting. But yeah, bread can work to slow down the speed, like you said.
The other thing we do, CO2 tank, and you thread a ball valve over the hose. Put the CO2 tank in it, burst it for 10 seconds. You can pull it out, and if you completely CO2 align back to the pool, you got a good, depending on the run, 5 to 10 seconds to get a ball valve glued on it and shut.
Oh, that's pretty cool.
Yeah, done that many times. That's
a cool idea.
Had this one out in Arboleta, man. Every single line I had to do that. It was brutal. It was a huge pool. Huge. 150,000 gallons. There was no way they were draining it to work on this equipment. Yeah.
And somebody didn't plumb it in, right?
Yeah, they didn't put service valves on anything.
What?
Yeah. It was nuts.
That's so wrong.
I was at that job for weeks. It was crazy.
That's so wrong, dude.
Yeah. So bad.
Because if you had the option to drain it a little bit and the equipment is at the right spot, you could also drain it to where it's level, right?
Yeah, or below.
I feel like I've been in that situation before where just getting the water to the same exact height as you said the impeller or the volute.
Yeah. Yep. Yeah, if you can do that, that's even more ideal.
Thanks, man. That helps a lot for sure.
Yeah.
I think people don't really realize that I've done it before all the time. You just pop a lid off and you're like, oh, damn.
I'm screwed.
Yeah. It just keeps
the O-ring blows off and floats away.
Yeah.
Call the customer.
Yeah.
Hey, I forgot to tell you, I'm not going to be able to come by the pool this week. If anybody else comes by, it's not me.
It's free drain day.
Yeah. That's awesome.
So let's get back to the kind of the equipment up top. If there's a leak above ground on a fitting or on a valve, what's the best way to go about fixing that?
Okay, so I'll give you a trick on a valve. If you have a valve and it's, let's say, on a vertical piece of pipe and you need to change it out, let's say a ball valve. If you cut right above the ball valve, and then if you cut at ground level, you can glue your ball valve up onto your stub very carefully as to not get glue into the ball mechanism. You can jam a rag in or whatever. And then you can heat bend in a little piece between the ground and the bottom of that valve. And it'll never look like anybody was there as long as your coupling is below dirt. Does that make sense? You got to know how to heat bend a little bit to do that, but that's something very easy to learn. You only got to heat it enough to just fold it in there.
So you're talking about like on a straight pipe
Yep.
that has a ball valve in the middle or something?
Exactly. Yep. So that's an easy way. The other thing is chip and peel. I mean, that's where chip and peel comes in big time. Changing out valves. If you can chip and peel, let's say a 3-way that has an elbow on both sides, you can chip those elbows off. You're like starting fresh. I mean, new 90s go on and you're done. Never can tell you were there. Paint it and you're out of there.
So how would you cut that on a 3-way?
So you scrap the 3-way. You just cut let's say the 3-way was leaking. You just cut that sucker out.
Like on the 3-way?
You cut
right
it
at the 3-way?
You cut it like where the center of the fitting is. So basically you cut the fitting in half.
Okay.
Because your two pieces of pipe meet. So you would cut it right where the you don't want to cut onto the side that you're trying to save the pipe. You want to cut the other side. Right. And the idea is to get it down to where it's just the pipe with just that little piece of ring on there. And then you cut the ring, pop it off, and you're off to the races.
And you have to sandpaper that off and clean it up to reuse it.
Primer it. Sometimes you use a hacksaw blade sometimes to scrape it off.
You usually put like a 2-way valve going to the like pop-up modules.
If it's below water or in general?
Yeah, I was just, I guess maybe some cases you might not need. I was just thinking of one that we had that was difficult because the water kept coming up and there was no valve for it.
Yeah.
Yeah, especially
And
if
it had to get drained to a certain.
That's an install error. You should be installing those above. The clamp should be above water height always. If you do have to put it in a room, we do a double service valve. So a double service valve is a check valve and a 2-way. The 2-way goes between the check valve and the pool. And the reason you do that is because check valves are a serviceable item more so than a 2-way, because a check valve open, close, open, close, open, close. So you can close the 2-way to service your check valve. So when we do put those underwater, that's how we do those.
Yeah, please put them above.
I know, it sucks. It's scary too.
I know.
You're taking the clamp off and you just don't know what to expect.
Yeah, that happened up at the one in Desert Mountain. We had to call and get someone to drain it and stuff. Yeah, that was rough.
That's a bummer.
So is there any like flow meters or anything that you would put on the plumbing or on the pump or anything like that you would recommend in order to get some key numbers for, say, even like programming, the pump for speeds and RPM or flow? Is there anything that you recommend for that?
Well, a vac gauge and a pressure gauge in the suction and return port on a pump will do wonders for you. Of course, nowadays with the VSF, it'll give you a readout of what it's doing in terms of GPM. But if you wanted to nerd out and do that, you could do your own TDH calc. Flow meters, for sure. A&A In-Floor Systems, they have a product called a FlowViz that pairs with theirs, which is a flow meter, so you can actually see what the flow is going to the unit. That's by H2O Flow Controls. They make that. Nice thing about that flow meter is there's no prerequisite for straight runoff pipe before or after, whereas a blue-white flow meter typically needs a lot of straight, non-turbulent flow before the flow meter. You don't typically see that people give it that, but...
And how do you install that?
It looks like a check valve, so it's a socket fit. So you just glue right into it.
So you pretty much just like cut in the plumbing and then you would just kind of put it.
Yep, you would just need 6 inches of straight pipe. That's probably what it takes to get in a 2-inch one, and you're set, and then you can see it. But again, with the new IntelliFlows, which is what everybody's pretty much using, there's very little need to do any sort of like manual monitoring or manual checking of what that system's doing. So it's pretty good. It's cool that we've gone to that.
Yeah. I'm just thinking for when you're installing a new pump and you're putting new speeds in, because we're constantly removing single speed pumps and we're selling them that this pump is going to be less, money on your electric bill, and it's going to be quieter, and it's going to be all these different things. But in order to do that, we need to know the size of the pool. We need to know what's actually going on inside of the plumbing. And I don't think that there's a lot of people that input the data the way that they should.
Yeah, I mean, and again, that's what's cool about that new one is you can see the amount of watts it's using. I mean, you can really like keep your thumb on the pulse.
On the pump?
Yeah.
Yeah.
On the pump. Because that's really where all the data is right there at the pump.
For sure. So what is something that you should never do in plumbing?
Couple things, but I'd say the main one is don't overuse 90s. Again, 90s are not as bad as everybody probably thinks they are. If you do the math on them, they're not that bad, but try not to use unnecessary 90s or unnecessary fittings in general. Don't use a combination of 90s back to back. That's a major thing. It's typically people will use double 90s if making it work with a 4590 was an issue, or maybe you're trying to go fast. It's like the easy way out, right? You're dealing with 2 axis only, X and Y or whatever, Z, whatever it is, but you're only dealing with up, down, left, right. So that's a kind of like a cheat way to get something done fast. I would say always try and plan it out to use as few fittings as possible and try not to use a combination of 90s. Another never is you never reduce a branch leg before you meet the feed manifold or the feed loop. And what that means is if you're plumbing out to a pool and the feed going to your features is 2.5 inch, and let's say there's a loop or a manifold, you don't reduce that leg before you get to that manifold, because you want to carry that volume of water all the way into the manifold. Too many times I see people run that line all the way, get right to where they're going to build their loop, and then they step the size down right before it. You want to carry it all the way through. There's a fitting called a bullhead fitting. They shouldn't even sell that fitting. It's at Cloud Supply and other places that sell. And exactly what that fitting is it's a 2-inch socket and 1.5 inch branch on the top. It's like just a waste, I think.
It's kind of like always trying your best not to disrupt the water flow.
Yeah.
Because you're talking about less fittings, less 90s, things like that, because those are all things that it's making it more difficult for the water to get to where it needs to go.
Right. Yeah, it's friction loss. So the less you have of those, the less friction loss you have, the less strength you need from the pump. So, and I think the third one really quick I never do is always try and install equipment so it's serviceable. That's a big struggle for us, like we talked about earlier, trying to get stuff in small areas, but just pay attention to like a motor that's got to come off, or the pump. Don't put your pump under something that you can't, your filter under something you can't remove the lid to service the cartridges. Just pay attention to what you're doing. Make sure everything's serviceable so you don't end up on that hashtag plumb fails, man.
Yeah. Is there any place, anything besides obviously the podcast and following you, of course, on Instagram, that what should people be doing to better themselves and educating themselves specifically right now to plumbing and hydraulics? What do you suggest? Has there been any type of literature out there or training that you thought was pretty solid? Because as you know, at the end of the day, we like you so much because you're actually in the trenches and you can still go out there at any given time and do the actual work. And we've always appreciated that because there's a lot of people that they know some things, but they haven't been in the field in maybe 10, 15 years, and things are constantly evolving and changing. But back to the education, is there anything that you recommend?
Yeah, I would say anybody can go get right off the internet friction loss charts, pressure drop charts for PVC. You can get equivalent foot of pipe for fittings. Start to study that stuff and try and get an understanding of how that works. For formal education, I know that WU does their fluid hydraulics course. I think that's probably the most formal shot at it. I took that in 2007, back a long time ago in Vegas, but it's been a while. But there's that course. But everything that that you need is online. You could go find those tools, nomographs, anything that you need to try and start to get your head around it is readily available. If you go to most pump manufacturer sites, Pentair has resources, Grundfos has resources, all those guys, you could learn a lot just by going out there and plugging in, some of the terminology that we talked about today, suction lift. You could plug in flooded suction and you'll get some good stuff. I have a kit that I built for myself and my employees, just mainly my managers, but basically that kind of combines and abbreviates all that. That's how I learned most, was just by wanting to understand what those terms were, what is net positive, head, and all these things. And you just go out and it's like a rabbit hole. You just start to learn. And it's really cool. I think that's why people get really interested in the hydraulics, because there's really a lot going on. Water is super interesting. The way it works is interesting. And like I said, it's readily available online and through WU too. So
very good. Thank you very much, Justin. Is there anything that you'd like to add before we end this show?
I don't think so. In the future, I hope we can maybe do a hydraulic intense interview and maybe really whet some people's appetites.
Oh yeah. Well, many more episodes to come, more technical stuff. We're really excited for that because we just think that this was a great talk, because there's a lot of things that me personally, I definitely did not know when it came to plumbing. And this, you're right. It's a lot more interesting. Like even just doing the research prior to today was like pretty cool, and just seeing the different videos and just the evolution of plumbing and hydraulics since, you're talking about from way back in the day. And it's really cool to see people like yourself just raising the bar every day and what's possible. Because it's like you've got a dream of building this pool or whatever it may be, but making it so that it's possible to move that water and keep it clean and do all the different things that it needs to do. So thank you very much. And once again, we really appreciate you being on the show with us.
Ty, thanks, man. Greg, thank you. It's great, man. Great beer.
Yeah.
Hey, Pool Chasers. Thanks for checking out this episode. Did you know that each episode has its own page on our website? This is where you can find more information about the guest and episode topic, as well as all the resources that we discuss throughout the show. To get to the webpage, click the link below. Also below, you will find links to the sponsors of the show, as well as links to follow us on our social media channels. On our channels, you will find some of our favorite clips and bonus material. Please follow us on Instagram, Facebook, Twitter, and YouTube. Our tag is Pool Chasers. We also have a Facebook group for the Pool Chasers community. Here you will find like-minded professionals all looking to make each other better. One last thing. If the episode has brought you value, please check out our Patreon page to support us. And if you could please rate and review the podcast, we would love to hear what your favorite topics are. Thank you for your time and your ear.
See you out there, Pool Chasers.